Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 24th, 2025, just yesterday. This paper introduces AutoEnv, a framework that can automatically generate diverse environments for agents at about $4.12 per environment, and shows that 7 leading language models only reach about 12 to 49% of the possible reward across these worlds. The paper is titled AutoEnv, Automated Environments for Measuring Cross-Environment Agent Learning. And as we will see later, the results raise some tough questions about how agents really learn to generalize across very different tasks. Figure 1 shows why cross-environment learning is fundamentally different from just getting better in one world. On the left, the agent gathers trajectories in a single environment and only updates its internal model and agent code. On the right, trajectories from many environments also update a shared learning procedure, so the agent gradually learns how to adapt its strategy to new rules. Figure 2 shows how AutoEnv actually turns a high-level game idea into a runnable environment for agents. The left panel encodes the environment theme as a structured description language, which lists states, actions, rewards, and how observations and skins should look. The middle pipeline lets a coding agent write initial code, test it, self-repair bugs, then generate levels and run reliability checks. The right side exposes the 3 abstraction layers, base ENV, observation ENV, and skin ENV, so designers can separately control dynamics, what the agent sees, and how that information is rendered. Table 1 spells out what kinds of worlds AutoEnv 36 actually contains. The table shows that rewards split evenly between binary win or lose setups and accumulative score-based setups, and observations lean slightly toward partial information, which better reflects real tasks. Semantic columns report that most environments use intuitive descriptions, while a smaller group intentionally misleads the agent. The bottom rows report moderate complexity, with roughly 6 available actions and around 470 lines of code per environment. While Table 1 summarized what kinds of worlds AutoEnv 36 contains, Table 3 shows how today's best language model agents actually perform in those worlds. The table reports normalized reward, which is a score scaled so that different tasks are comparable, along with variability and average number of steps. The strongest model, O3, reaches about 49% reward, while smaller models like GPT-4o Mini stay near 12%. Averages over all models reveal that binary rewards and fully observed environments are noticeably easier than accumulative rewards and partially observed ones. Figure 3 shows that learning methods lose their punch as environments become more diverse. The left panel plots how the best possible performance gain over baseline shrinks when you include more environments, so single methods give big boosts on a few worlds but almost none on many others. The right panel tracks the extra gain from combining multiple methods, which rises when you allow more methods yet flattens quickly. This pattern means that simply piling on more fixed strategies offers limited payoff, and what really matters is choosing methods that match each environment. Together, these curves highlight both the difficulty and the remaining headroom for environment adaptive learning. So the big picture is that AutoEnv gives us a cheap, systematic way to generate many diverse worlds, and current language model agents still struggle badly in that setting. That gap suggests we need learning procedures that adapt as flexibly as the agents themselves. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.